Hi, my name is Sean Harris and I'm an aspiring game developer. In this video presentation I will be showcasing what I've been working on during the school training period of summer 2021. The primary goal for this period was to learn the Unreal Engine thoroughly enough to switch to it as my new primary tool for game development. I went about achieving this goal by spending the first few weeks of the summer participating in 2 Udemy courses I had bought for the occasion, after which I began applying the newfound knowledge into an Unreal project I named Tellurium, which I subsequently spent the rest of the summer on and is also the focus of this presentation. With Tellurium, I wanted to focus on my personal growth as a game developer rather than that of the project as some potential game, since I figured that was the more effective way to learn Unreal within this time frame. What this means in practice is that Tellurium became more akin to a sort of gameplay lab, one I could use to get to grips with the Unreal editor and its various tools and experiment with gameplay ideas and mechanics I was interested in, without having to spend time on things like presentation or polish. This framing also meant I could get into more advanced topics, even if it meant reading up on theory for hours on end, since I didn't need to be concerned with pushing a functioning game out in time for the deadline. In terms of learning Unreal, this project was a resounding success. In fact, the next game project I worked on turned out way better than I could have ever hoped for, all thanks to this time with Tellurium. But it's tough to make an interesting video about me basically just saying, yeah, I learned how to use a new game engine, so let's check out the technical details. Right, by the end of the summer I had the following things to show for my efforts. A player character with relatively complex movement and rotations, utilizing Euler angles, built using Unreal's character movement component as a base. Then a second, significantly more complex redesign of the character, entirely physics based, with quaternion rotations allowing for 6 degrees of freedom, built using a custom PID controller setup. And lastly, various prototype levels for testing said movement, although the work put into these pales in comparison to that of the characters, especially the second. And that's it. Now that might not look like a lot, but there's more here than meets the eye. Let me show you what's happening under the hood and I'm sure you'll agree. Little backstory. In a previous school project I had tried and failed miserably at developing a player character with similar capabilities as Tellurium's, things like physics-based movement, dynamic character rotations, etc. I knew what I was aiming for had been ambitious, but experiencing such failure made me question my abilities as a programmer nonetheless. So with Tellurium I stubbornly doubled down and once again focused all development efforts on the player character and mastering 3D rotations, wishing to prove to myself that I was wrong to give in to self-doubt. Here's how that desire affected design. The player character would possess an ability called jetting. Think a jetpack but meant for quick horizontal traversal rather than gaining altitude. It's a mechanic that I've already experimented with in some of my previous projects, but for Tellurium, the desire to integrate rotations took this mechanic to the next level by adding what are essentially rollerblades to the character, allowing it to do things like this. Eventually I even experimented with flight using an aviation model with 3 degrees of freedom. Without VFX or audio cues, these certainly lack some punch, but as a proof of concept I'm happy with them. There was the obvious risk of all of this feeling disorienting or leading to motion sickness, but as a concept it's badass and there was only one way to find out for sure, right? Okay, let's talk about the first character in a bit more detail. Despite this character being admittedly quite jank and basically just a prototype, developing it still took a substantial amount of time. To some degree because I was using Unreal for the first time, obviously, and the algorithms controlling these rotations aren't exactly simple, but even more so due to 3 key issues I had to solve during its development. The first issue, and one that probably took the most time to fix, is the deceptively simple sounding quirk in the previously mentioned character movement component that made it surprisingly difficult to work with when fast movement speeds were introduced, even before factoring all the wild rotations. See, the component doesn't actually interact natively with the engine's physics SDK. In other words, the physics are quote-unquote faked. This results in a number of unexpected behaviors, but the big one is the component not considering velocity in 3D. Notice how unnatural the jump arc is in this footage. Printing the component velocity as a debug message reveals the issue in full. Vertical velocity is, somehow, always 0, even when obviously moving upwards. With over 16,000 lines of code, the vast majority of which were way too advanced for me to edit safely, I unsurprisingly struggled a lot with this. My eventual hacky fix was to create a custom movement mode for the component, but I had to sacrifice a lot of its benefits to do so, making it less than ideal. The second major issue was dealing with the player controller class not being able to keep up with rotations exceeding 180 degrees. I won't talk about this one much, but in a nutshell I once again had to ditch the default control method for something custom made. The third and last issue is one that can't be escaped for long when rotating using Euler angles, namely gimbal lock. Here's a quick explanation of what gimbal lock is, lifted straight from Wikipedia. Gimbal lock is the loss of 1 degree of freedom in a 3-dimensional 3-gimbal mechanism that occurs when the axes of 2 of the 3 gimbals are driven into a parallel configuration, locking the system into rotating in a degenerate 2-dimensional space. Fun stuff. When I was working on the first character, solving gimbal lock felt way above my experience level, so I took the easy route instead and locked rotation to only happen automatically on the X and Y axes, which removed gimbal lock, sure, but also led to undesirable consequences like this horizontal jitter when doing loops. This is something that would come back to haunt me when working on the second character. The lack of physics made much of the rotating behavior feel quite bad, since angular momentum couldn't be simulated thanks to the movement component. That and the hacky nature of some of the other solutions made this character version feel like it was being pushed to do things that none of its pre-installed Unreal components were designed for. It feels rigid and overly complex for what it is, and further development would have most likely taken me on an arduous path of fixing a never-ending list of newly discovered unwanted behaviors. That being said, the amount I learned from my time with this little fella has been truly incredible, and when I came to the realization that the character concept was better implemented using physics, I felt ready for the challenge, because I already knew so much about the things I needed to be considering. So without further ado, let's take a look at character version 2.0, easily the biggest technical achievement of my programming career so far. It's basically just a remake of the first character, and in some respects it isn't even as feature rich, lacking some of the more automated rotations the first had, due to me not having the time to recreate them under the new framework. Despite this, the improvement to the proof of concept is huge. So what's different? Well, firstly, like already mentioned, this version is entirely physics driven. Movement, rotations, inertia, even the skeletal mesh and its animations, you name it. This means that angular momentum is maintained properly now, leading to far more realistic behavior. No longer is it considered a character class by Unreal either, rather it was built on a far simpler pawn class, which is as close as you can get to a clean slate without having to integrate the player controller yourself. Gimbal lock has been solved as it can now rotate on whatever axis it pleases, and just in general it's an upgrade in almost every way, the least of which is the massive increase in potential design directions it can be taken in thanks to physics simulations. The reason all of this just works now is mainly due to the following two things: quaternions as the solution for gimbal lock and PID controllers for all things physics. Let's start with quaternions since I have less to say about them. Now, I've always been a visual learner. For example, even after hundreds of hours of vector math, I still find myself rotating a desk toy to help visualize 3D space. So it's probably not surprising to hear that I had a lot of trouble wrapping my head around quaternions, since they operate in theoretical 4-dimensional space, and good luck visualizing a hypersphere. Despite this, I was really determined to figure them out for character 2, since I knew that if I actually could, I'd never have to worry about gimbal lock again. So, in tandem with researching PIDs, I stubbornly bashed my head against the figurative wall until I eventually got to the point where using them yielded some consistent results. Big shout out to ether.net/quaternions for enabling me to learn them in an efficient and interactive manner. Without this page, I doubt I'd have a success story to present here. Even after implementing a fully functional system using quaternions, I'd still be lying if I said I understood them properly, but I've come to realize that basically no one else does either, which is somewhat reassuring. But that's enough talk of quaternions, or I run the risk of getting my head spinning again, pun intended. For it's time for PIDs to take center stage. A PID, or Proportional Integral Derivative Controller, is a control loop mechanism employing feedback to automatically apply an accurate and responsive correction to a control function. That's a load of gibberish, so let's look at one in practice. To have physics-based movement, we need to move using force rather than translation and rotate using torque. But if I were to simply add force or torque in the direction I wanted to move or rotate in, the character would simply accelerate forever. This is the issue that PID controllers solve. By measuring the error, aka the difference between a target value and the current value, we can tune an algorithm to correct that error. In the case of rotations, for example, we can look at the quaternion we want our character orientation to match, then break that down into 3D Euler, have one PID for each individual axis that will then determine the shortest path needed to match the target orientation, as well as how much torque is needed to reach it. This happens every frame and can adapt on the fly to any external forces as well. This is how the character keeps its balance, even when standing still. And if you think about it, we humans are also able to stand thanks to what are essentially organic PID processes happening in the brain. Anyway, the system for movement is a simpler PI controller, but the fundamental idea is the same. It's just less aggressive in reaching its target value. If we had a PID controller for movement instead, the character could push objects that weigh multiple tons, because the algorithm would keep increasing the force until the target speed is reached, no matter what's in the way. Out of everything I studied or worked on, understanding and implementing these PID controllers was easily the most time consuming, it's not even close, but also the most rewarding, because I felt like a whole new realm of possibilities was unlocked to me. For example, I also used PIDs to create hover thrusters that I ended up using to improve the feel of the jetting ability, as well as creating these floating platforms that are indeed entirely physics driven as well. Some other things I made with PIDs include a camera stabilizer making rough terrain less uncomfortable to navigate through, a movement stabilizer that would keep the character in place if no input was given, which even takes inertia into account, something I'm honestly quite proud of. It also allows for the tweaking of the movement feel. The skeletal mesh is also in a physics state even when animating thanks to PIDs, etc, etc. The point is, the PIDs are wonderful and very useful even in their intimidating complexity. But this video is now getting quite long, so I think it's time to start wrapping things up. There's a lot I've left out, like how my efforts to make a grappling hook and or morning star led me down a rabbit hole of rope simulations, the frankly big effort put into having physics be frame rate independent, and my research on physics SDKs, like the difference between Epic's new Chaos engine and the tried and true NVIDIA PhysX, all of the level stuff, and of course the obvious things like blueprints, C++ and stuff about the editor. But I hope what I've shown you is at least enough to convince you that I've had indeed a very busy summer. The future of Tellurium is not one of abandonment. I'm planning on returning periodically to it between my other projects to gauge how much I've improved and to try new things in an already established test environment. I already have some things in mind, like dialing back some of the physics rotations, ironically, and implementing a sort of hybrid system between physics and non-physics movement, so I can create a more consistent game feel without sacrificing the physics sandbox. I also developed a big interest in physics engines themselves, and I've recently been granted access to mess around with the Havoc Physics Engine SDK, which I'm incredibly excited to sink my teeth in. In retrospect, I'm glad I decided against making Tellurium into a full-on game, since I feel I'd be substantially less comfortable with the editor if I had. Sure, because of this there's nothing in Tellurium that could be called complete, but as a reflection of my own personal growth I'd say it's pretty damn honest. I'm actually considering registering my most recent Unreal project into this year's Bit 1 student game competition, and I can say without a shadow of a doubt that it's thanks to my time with Tellurium that I have the confidence to do so. I'm currently just in love with developing games, and my infatuation with Unreal just keeps on growing, even as I begin to learn of its many imperfections. Who knows, perhaps Tellurium will one day serve as the base for a good, successful game, but even if it doesn't, I'll never forget its importance in shaping me. I have nothing but excitement for the bright future of this marvelous art form. Thanks for watching.